So now we're going to talk about social psychology as a science. Woo! So science has gotten a lot of flack recently. People just don't trust scientists, which is, in my humble, totally biased opinion, wrong, right? You feel free to disagree with me, but you're wrong. Science is great. Now, this is the thing. Why is science important? You are asking, or maybe you just read the top of the PowerPoint slide. Fair enough. So, science is an organized method of gathering and interpreting information, right? We have statistics, we have rules, we have ways that we speak about our results, right? If we have a scientific study and we get certain results, we don't say, well, this is the way it works throughout the world. We go, well, this is what we found in our study. This is what we expect to see in the world, but we're going to want to continue to do more testing, right? What often happens is a scientific study will be done. Sometimes it will be done rigorously, sometimes it won't be, but it somehow gets published. And then people are like, well, this is what this study said, so this is the way that things are definitively. But no actual scientist will say, this is the way things are forever. So, one important thing to realize is that science is never really done. Whenever a study is done, we go, okay, this is good information, but could this have been done wrong, right? Why don't we try this with a different sample size? Why don't we do this with a different population, right? Why don't we change some of the variables? Why don't we change how we measure these variables? So we're continuing to learn and we're continuing to gather data so we can understand the thing that we're trying to measure. So science sets these ground rules that allows us to go, okay, well, we're not just going to rely on the fact that, my uncle said that this works, so it must be the only way it works because that's what my uncle said. We're going to go, well, let's doubt what the uncle said and let's really find out for ourselves. And then let's let other people doubt it. So together we can figure out the truth. So in science, we are trying to figure out the relationship between two variables, the independent and dependent variable. The independent variable is the one that we assume affects the dependent variable. Now, in some studies, we're looking for just a correlation. Sometimes we're looking for causation. But you may have heard at some point the phrase, correlation does not imply causation. Now, if you've listened to a bunch of these lectures, sometimes I retake it, a recording if my cat meows, sometimes I don't. But sometimes what I think is, man, my cat only meows at me when I'm trying to do a recording, right? Because, as you have heard, when I record, my cat does meow at me. Now, is it something about pulling up my podcast mic and lecturing about psychology that makes my cat meow? No. Me recording does not cause my cat to meow. Now, I notice when my cat meows when I'm recording, but it doesn't cause that. He meows when I'm on the phone. Please stop. You did it once and you proved the point. You proved the point already. You don't need to do it again. You're getting greedy now. Don't get on the box. Get off the box. You go in the box, not on top of the box. It's like living with a child. Aside from the fact that you would, go to jail if you made a child poop in a box. So the my assumption is that me talking on this podcast mic, right, makes my cat meow, but it's just related, right? They do sometimes happen at the same time. Sometimes when I'm just watching TV and not talking, my cat will meow at me. Sometimes when my alarm goes off and I snooze it, my cat will meow at me, right? My cat meows at me a lot. It's almost like it's the only way my cat knows how to communicate. Am I right? Cats. So the this idea about understanding variables, it's important to understand that just because two things are related to one another doesn't necessarily mean that one thing causes the other. When we're doing experiments, there's one important thing that you should know. It's called random assignment. Now, let's say I have two groups, right? One of them gets the drug, the other gets no drug, right? I could just say, okay, who wants to take this experimental drug and who doesn't want to take this experimental drug? And if I have 30 people, maybe 15 people select the drug, and some people go, I don't want to do the drug, right? By letting people select which groups they're going to be in, I might not be comparing equivalent groups because there might be some reason why certain people are more likely to want to try the drug. Maybe they're sicker. Maybe they're the types of people who enjoy taking risks. Maybe the other group has more anxiety, right? So if there's some difference between the groups, then we're going to say that, like, hey, the reason why that person or that group did better might not be because of your independent variable, which what is the thing that you want to have an effect on the dependent variable. I'm on my mic, right? So of course my cat's talking to me. So you want to make sure that it's not a third variable that's affecting the dependent variable. You want to make sure that it's the independent variable. So if there's this difference between the groups, that's not your independent variable, which in this case would be the drug. If you have this third variable, that's anxiety or how sick they are, right? That's going to affect your results. So what you do is you randomly assign people into both groups. So people don't know going into it what group they're going to be in, but by randomly assigning them, so it could be a coin flip, and there are a variety of other ways that you can make sure that people have an equal chance of being in either group, you ensure that your groups are equivalent. So you can't do research without issues. So one issue is control versus impact. Then we have realism, deception, replication, ethics, and misuse. So when you're doing a study, you want to only focus on the variables that you're trying to measure, right? So if I want to measure the effect of a specific drug, I randomly assign people into two different groups, and then I measure so maybe it's like a antidepressant. So I measure their depressant or the levels of depression 2, 3, 4 months after giving them the drug, right? Now, you are probably thinking, because you are very smart, and I know that you're already thinking about this, but aren't there other situational factors that you can't control for? What do you mean? Well, like their diet, their levels of stress, right? Won't those make a difference? Oh, you're right. So I should, put them in a controlled environment, expose them to similar levels of stress, make sure that they have the same diet. Um, and what will happen is I will go, okay, well, now I've eliminated all these potential variables that could affect my relationship between the independent variable and the dependent variable. But now the situation has become so sterile and controlled that any results that I have don't really represent what I'd see in the real world, right? So I know that under very controlled circumstances, I'm going to see these results, but in the real world, people aren't going to be in very controlled circumstances. So, if you remember the show The Biggest Loser, or if there is another show now, which is I'm actually not sure if The Biggest Loser is still on TV, but if there is another reality show about like people losing significant amounts of weight, those are very specific and controlled environments in which people are put on a strict diet and have people yelling at them all the time to do specific exercises at specific times. And that's not what the real world is, right? If you're on a reality TV show, then they're not going to let you go to the grocery store at midnight to try and get some cupcakes, right? When you're back in the real world and you have a craving for cupcakes, you're probably going to go get cupcakes, right? If you don't have television producers with cameras watching you on the treadmill, you might not hit the treadmill as often. So these very specific and controlled environments sometimes don't reflect what we would actually see in the real world. So sometimes it's very hard to know if what we see in a study actually means anything, actually has any impact. There's also the idea of realism, right? Now, if I put you into a video game world and give you a gun and I say, okay, if you kill any innocent people in the game, then you're going to be punished in the game, right? Now, it's a video game. I'm not sure if you've played video games, but sometimes in a video game, you're like, well, like I'm in this person's house and they have 3 gold pieces on that table. Well, what happened if I steal it, right? It's a video game. Worst thing that happens is, they get mad at you and then you like fight them and then game over because you suck at the game and you get killed by a random person. That is, like not a reflection of what you would do in the real world if you are at somebody's house and they leave $20 on the table. Just because you do it in a video game doesn't mean you do it in real life, right? So, in these fictionalized situations that we sometimes present in a social psychology study, you have to realize that how people behave in a fictionalized environment is going to be different than how they behave in the real world. It could also be the reverse, right? I'm very polite in this environment. So if, my, if I'm doing a study on honesty and I use all my students on for this study, and they know that I'm grading them and I'm measuring honesty, would my students maybe behave a little differently because, you know, it's not the real world and they have some sort of impression that they're trying to manage, right? I don't know. I couldn't think of any reason why a student would ever lie to a professor. So, realism is very important. Speaking of lying, let's talk about deception. Now, sometimes in research studies, we have to lie to our participants, right? So, let's say I wanted to do a study where I'm trying to see how uh, likely it is for one person to hurt another person, right? If that person is being told by some authority figure that they have to hurt that other person. So I put on a lab coat, I get a friend to pretend to be a student. And I find random people who will pretend to be teachers, and I tell them every time the student gets an answer wrong, they're in the room next door, you're going to flip this switch, and they'll receive an electrical shock, right? And for every wrong answer, you also increase the intensity of the shock. Now, is there anything wrong with this? Well, yes, because I don't actually want to kill my friends, so I'm going to have them pretend that they're getting shocked. I'll have them pre-record their shocks so that every time the switch is flipped, a pre-recorded message of them going, "Ah, that hurts," plays. Right now, it's all fun and games because nobody actually gets hurt, aside from the fact that I lied to somebody. Now, just so you guys know, this hopefully you're familiar with Milgram's experiment, so you don't think that I was like actually electrocuting people. But one of the big issues with Milgram's experiment was deception, because a lot of people actually thought for a moment that they killed somebody, right? Or at the very least, harmed them severely. So deception is an issue because we oftentimes use deception, even if it's just giving a placebo pill, right? When you're doing your drug trial, you give some people the actual drug. You tell some people that they're getting the drug, but they're actually getting basically a sugar pill. So you're lying to them. But if you didn't lie to them, right, then they wouldn't take the study seriously and you wouldn't really be able to determine if the drug works. So deception is useful, but it does bring up some ethical issues. Then we have replication. So if you remember, I was talking about how in science we doubt each other, right? So I test something and then you test it again, and then somebody changes a variable and tests it again, and somebody changes how we define a variable or uses a different measurement of that variable and then tests it again. And you get like 30 different tests of the same thing, right? Now, where do these studies end up? Well, they're published in journals. And you can't just get something published in a journal if you do a study, right? It has to be approved by the editors of the journal, and it has to pass a peer review process. Now, if you're a journal publisher, you want people to be interested in what your journal has to offer. If your journal in one issue doesn't show anything new and exciting, right, then it's going to be harder to keep subscriptions. Unfortunately, people buy things based off of whether or not it's new and exciting and fun, right? That's why our news is controlled by big corporations, because you need to make money in order to share information. So journals are incentivized to publish things that are new and exciting. 5 replication studies on something that we already know is not new and exciting. So unfortunately, replication doesn't happen as much as it should, if at all. Now, the scientific community has started to become more aware of that, and that is changing, but it's still a very big issue. So usually what we do, right, we have this one study and then we just call it that. We don't replicate it at all, because we're like, oh no, we got it. Let's move on to something else. But what we really should be doing is testing something, retesting it, and testing it in as many different ways as possible until we fully understand a phenomena. And so I alluded to this, but this is Justice. She is blind. When we're looking at research, we have to think about ethics, right? Is the data that we're publishing fraudulent? Are we trying to do a little fudging of the numbers to make our results look better? Are we harming people? And is the amount of harm that we're exposing our participants to allowable, right? If I'm doing a drug trial, then there's a chance that people could get sick or die. There's a chance that people can have these really negative and terrible side effects as a result of taking a drug. But I'm balancing that out by maybe discovering a drug that could help a lot of people. So this is where ethics comes into play, right? How much harm is okay? Am I respecting people's rights and dignity, right? Is there justice for the participants? Am I being honest, right? Am I doing anything unethical? So the APA has an ethics code, and if you're doing psychological research, you have to abide by it, right? It's very important that we respect and protect our participants. There's no scientific discovery that is worth throwing away the lives of individuals and ignoring their rights. So ethics is very important. The last thing that we're going to talk about is misuse. As I kind of alluded to before, sometimes what ends up happening is you publish something and you say, well, these are what the results say. It's not set in stone as the truth, but we definitely need more research. But it's promising, right? And then somebody sees your article and they're like, they just read the heading and they're like, chocolate cures cancer. It's like, that's not what I said. I said that intake of cacao beans by rats has been associated with lower rates of a specific form of rat cancer. It does not cure all cancer. And then all of a sudden, there's like a Vice article that's like, why you should be eating more cancer or more chocolate, not more cancer. Please don't eat cancer, guys. Why you should be eating more chocolate if you want to live a longer life, right? So, unfortunately, what can happen is once information is published, it could be spread. And any spread of that information comes with a risk of it being misinterpreted, right? A lot of things get spread that are wrong. And I could go through and list all the things, but I'll just list like a couple. So one, vaccines don't cause autism. There was a correlative study that found a link between vaccines and autism. One, correlation does not imply causation. So it could be that autism causes vaccines. It doesn't. Or it could also just be that because we increase our, like, the more any disorder becomes known, the more people go, oh, that's the reason why I have these symptoms. I just thought that, like, I was weird, but like now there's a name for what I've been experiencing, right? So over time, you see diagnoses of specific disorders go up. And also, because we're an industrialized nation, the more things that we can prevent with immunizations, the more people are going to get vaccinated, right? Uh, and then that same study, which quote unquote proved this link, was later discredited by the original author, right? But now that that original study, even though the original author was like, no, sorry, I'm so sorry, this is wrong, it's incorrect, right? It's being misused, and now there's a whole anti-vaxxer movement, right? And even though vaccines are relatively safe, people have all this misinformation about them because information can be misused. Or people point to some of the chemicals in vaccinations as proof that they shouldn't be injected in our bodies. Now, there are, like anything in everything, is toxic in certain amounts. You can drink too much water and kill yourself, right? But nobody's saying we should stop drinking water. Actually, a lot of people recommend that you drink more water than your body actually needs, right? So we have to be very careful because sometimes the information that we find in our studies can be misused. Now, we do our best to qualify and explain so that people understand, but unfortunately, people sometimes just read article headings and they're like, well, I fully understand this 20-page article because I read the heading, right? It's an unfortunate side effect of the accessibility of information because misinformation spreads faster than it can be contained. But that is a thing that you do within science. So, one more slide and then we're done. You thought you were going to learn something. I gotcha. I'm just going to give you a genuine thanks. Thanks for being around this entire semester. It has been fun having you in class. Yes, you. You think this is a generic message that everybody hears? No. I hacked into YouTube and made it so that you specifically, and I'd say your name, but you already know that I know your name. You specifically would hear this message. Thank you. I know it's been a rough semester, but we did it. We're here at the end. Take that final, do great, and I will see you around.